All right, so here is just a quick video on differential equations. So differential equations are basically an equation that you need to find a function to. All right, so you're going to find an equation that actually has a variable in it. So in order to solve differential equations, the first step, okay, is to classify the differential equation. All right, and that means first, and I'm going to go through these, identify if the equation is separable. So we'll talk about that here in a second. Identify the order. Identify if it's linear and nonlinear. Is it constant coefficient? Is it homogeneous and non-homogeneous? Because when you do this, it'll help you identify where you need to go to find the solutions, or some of the solutions I'm going to tell you now. So if the equation is separable, meaning here we have 9y prime plus 4x equals 0. That means we can separate the variables so we have y's and x's on both sides. If we can do that, that's the easiest form of a differential equation, because you just have to integrate both sides, and then you can then solve for your variable y in this case. All right, and also to note that y prime is dy dx, and we're solving for y in terms of x. Y is a function of x. Okay, and that's what we see down there. So separation of variables is the easiest method. If you find that it's a first order linear, what we can do is, here's a general form, we can multiply by the integrating factor, which we'll call e to the integral of ax dx. We multiply every term by that factor. Okay, and you notice that I have it in red here in our basic equation. So here's an example. We have y prime plus 2 over x times y equals x. So our integrating factor, we'll call u, equals e to the ax dx. So whatever's in front of our y coefficient, okay, which is the 2x, is our a of x. Then we're going to integrate that, and we end up getting e to the 2 ln of x, and that becomes x squared. Okay, so make sure when you find this, I'm going to circle this, 2 over x, that it's in front of the y term, and anything that you have in front of this, you have to make sure that this has a coefficient of 1. All right. So that's our integrating factor, x squared. So we multiply every term by x squared. Okay. And come to find out the stuff on the left side, we can shrink. So x squared plus y prime plus 2xy is actually equal to x squared times y raised to the prime, using the product rule. So that's a little shortcut. That's nice. So we end up getting, here in purple, x squared times y all to the prime equals x cubed. Then we integrate both sides, and we end up getting our solution for y. All right. So now, if it's second order linear constant coefficients, all right, and so just a few things. Linear, meaning that even though this is a second order differential equation, so if we put a note over here, y double prime is d squared y dx squared. Okay, that's second order. All right, we'll go with constant coefficients here. That means anything in front, we have a 1 here, we have a 5 here, we have a 6 here. Oops, sorry, this should be prime. They're constant. All right, and also anything in front of, in terms of the y, like here we could have y squared here, and that would make it a linear or nonlinear term. You don't want to do that. Okay, so again, second order, second derivative, linear because all these terms are derivatives or second derivatives. There's nothing to squared or cubed for y. and then anything in front of the variables, the derivatives or the constants, are constant. All right. So here we have, I'll erase that, our black differential equation with these conditions. Either they're initial conditions or boundary conditions. All right, and initial conditions, anytime you deal with time, they're going to be initial, and anything that deals with like boundaries, pretty much with x, they're boundary conditions. So what we do for this case is it's homogeneous, meaning it equals 0. We guess a solution where y equals e to the rx. We take the derivative, the second derivative, and then we plug those derivatives back into the differential equation. So that's what you see here in blue. All right, that's the second derivative, first derivative times phi, and the just the regular guess of y times 6. Okay, then we factor out e to the rx, and what we need to do is look at the inside of these parentheses that are equal to 0. All right, so we have two conditions, and I'm going to put subscripts, R1 and R2. So just a note, there are actually 3 cases that you can get from this kind of case. You can have R1 and R2 be real and different, which we have right now. We could have a case where R1 equals R2, and we could also have a case where R1 and R2 are complex. And there's different solutions for each one, and we're just going to look right now at this first case. So the first case is basically the total solution is a combination of both values. So C1 e to the 2x plus C2 e to the 3x. And then we have to apply either initial conditions or boundary conditions. So here we did our first condition. We said that at y at x equal to 0 is 2. So we just plug in 2 for y, and then wherever you see x is 0. So we end up getting this for our first equation. Our second equation means that this derivative is equal to 1. So we got to take the derivative, and that value is 1, and then plug in wherever x is 0. Right. So we have 2 equations, 2 unknowns. You can do algebra, you can do matrix, linear algebra, whatever to find those values. So now, if it's second order linear constant coefficients non-homogeneous, okay, which you see here, then the solution is actually the homogeneous part plus a particular. So we already found the homogeneous from above. So in order to find the particular, we guess. And what we need to do is we need to look at the coefficients. All right, we need to put in coefficients based on what we have here. If you notice, we have, we'll go back up to the top here, right here. We have, on the right side of this equation, we have x squared, x, and then a number. So our guess is going to be a to the x squared plus bx plus c. All right, so that's our particular right there. If the right side of this equation was just equal to a number, then yp would just be equal to c. Okay? So you have to always match a coefficient with what you're looking at. So then what we're going to do is take the derivative, which is here. Take the second derivative. Then we're going to plug those values back into the differential equation in blue. Okay? So we have the second derivative, we have the first derivative, we have the solution that we guessed, and it equals the right-hand side. Okay, we factor out, we look at what's in front of the coefficients, okay, and then we match coefficients. So 6a x squared, 6a equals 1, so we need to match those. Same with the x and then the constants. Then we'll have 3 equations, 3 unknowns, and this is our particular. We plug it back in. This is our overall solution. Okay, and then we need to apply boundary conditions or initial conditions to finally find our values for C2 and C1. So this is a quick video about differential equations, all right, to help you get started if you're ever stuck. And remember, differential equations, you need to find the missing function. And always follow these first step. Classify it. Is it separable? What's the order? Is it linear? Is it constant coefficients? Is it homogeneous or non-homogeneous? All right, if you find that the equation doesn't satisfy some of these, an easier solution sometimes would be to solve it numerically, all right, instead of solving it theoretically. All right, I hope you enjoyed, and good luck.